Good afternoon. I'd like to welcome everybody to the PermaTrak webinar on how to build a boardwalk through a wetland. A couple of housekeeping items here before we get started. We are recording today's webinar, and we will send out a link so that you can share that with anybody who was not able to attend. We'll also share copies of the slides as well. So to get started here, I'd like to give a quick introduction to today's speakers. My name is John Pyle. I'm the Vice President of Sales and Marketing for PermaTrak. I'm a graduate of Clemson University and a registered professional engineer. We also have with us John Dove. He is our project consultant in the Dallas-Fort Worth area. He handles the South Central U.S. He has a bachelor's in civil engineering from the Citadel, as well as a master's in environmental engineering from Auburn. And we have Jason Philbin, who is the president of PermaTrak. He's based in our Charlotte office. He has a undergraduate and master's in structural engineering from Kentucky. He is a professional engineer in 34 states. Joining us, but not speaking, will be Cary. She's our project consultant in the Southeast. She has a degree in civil engineering from Case Western. So one thing, because of the size of the audience today, if you do have some questions, please drop them in the Q&A box at the bottom of the screen. If you don't see a Q&A box, if you click on the More button, you'll see a Q&A box. Just check on that and it'll show up. So to get started here, a little background on what PermaTrak is. PermaTrak was founded in the mid-90s by a landscape architect in Australia. So he was looking for a more durable option for boardwalks in the harsh environment in Australia. So he was looking for a more durable option in the harsh environment in Australia. In 2010, PermaTrak North America was brought to the U.S. by Jason and his business partner, Tim Beach. So we wanted to give a quick overview here in case you're not familiar with what PermaTrak is. It's a precast concrete boardwalk system consisting of precast concrete beams that are going to span from pier to pier, and then you have precast concrete treads that make up the walking surface that are going to be turned 90 degrees to the beams to create your walking surface. Those beams typically are going to span anywhere from 10 feet up to 40 feet in some of our more custom applications. So we have a lot of flexibility in beam lengths. The treads can accommodate clear widths anywhere from 4 feet wide up to 14 feet wide with our standard options. We can go bigger than that as needed. And then we can pair that with precast concrete abutments, curbs, as well as we have a precast concrete pier system. So we can do a fully precast system. But today we want to focus specifically on wetland applications. So, why are we going to spend an hour on this particular topic of building a boardwalk top down? And, to give a little bit of context to that, so we look at probably hundreds of projects in the course of a year in the early design phase. And most of them start off with the question of, how are we going to build this boardwalk through a wetland? And so the environmental permit, may say to limit disturbances in the wetland, which is going to imply that the boardwalk needs to be built top down. But what does that really mean? It can mean different things to different people involved. So the designer, he may specify it one way, but depending on how that language reads in the specification, the contractor may interpret it a different way. So they may bid it with a different method in mind, which has a big impact on the overall bid prices that come in, and may or may not then come in over budget as a result, or could lead to change orders down the line. So these can have very big impacts on the overall project as you go through. So we're going to walk through, what does top-down construction actually mean? Talk about the three different methods of constructing using top-down methods, kind of the relative cost of each of those methods compared to a traditional from the ground construction. And talk about how long that might take. And we'll also look at three different different project examples. So a quick overview of the agenda. So we're going to talk about kind of when that decision gets made. Jason will take us through the installation process, specifically then the three different methods of installation approaches. John's going to talk about some case studies, and then I'll finish up by going through what the types of things that you want to make sure that you include in your specifications. And as I mentioned, we'll address questions here at the end of the presentation. So I'll turn it over to Jason to get things going.
Yeah, thank you, John. Like John said, PermaTrak has been installed, can make claim to over 750 structures. Those are completed, installed structures inside North America. And of those projects, many of those we've talked about, is top-down construction the right choice? Does it make sense? Can it fit the budget? And in addition to 750 installed structures, we've also evaluated whether or not PermaTrak is an option or not for over 3,000 structures. So we pulled together this slide deck for you. There's about 40 slides. I'm going to go through 15 slides and explain to you some of the information we've learned in 16 years in talking about this topic that is definitely beneficial, and it can impact greatly on the cost. And I'm going to go through 15 slides here really quickly. Let's get right to the first one. So the design phase undoubtedly is the best time to be talking about construction methodology. You as a consultant, and I've seen the list of attendees, most of you are design consultants, you're representing the owner. It's your role to make a decision on what the best material is for a boardwalk, but also to have a really good understanding of how that particular material can be built. And like John said, when top-down construction is on the table as a topic of discussion, here are some of the drivers that you need to be thinking about that might affect whether or not top-down is required, if it's a need or if it's a want. So the first item is the most common, permit requirements. So there's probably some people on this call who are very knowledgeable about permitting and the Army Corps of Engineers. Well, if you're familiar with the Clean Water Act, there's a section 404 that has these nationwide permits that spell out when and where you can cross through certain areas. And these nationwide permits there's nationwide permit 10, there's nationwide permit 14, and these specific permits allow structures inside protected areas. So think about protected wetlands or navigable rivers and waterways or protected species areas. These are specific things that the Corps of Engineers gets very specific in what you can or can't do. The site conditions themselves, think about where the boardwalk is going. We've had boardwalks that are on the side of a cliff, and that is extremely difficult to build a boardwalk on the side of a slope. Maybe it's not a cliff, maybe it's the side of a road. Maybe you've evaluated a retaining wall versus a boardwalk option. Maybe building the boardwalk can only be done with top-down construction, right? So think about the site conditions. Does it necessitate the discussion of top-down construction? In addition to that, the equipment limitations. Sometimes you simply can't put the equipment at the site that you want. It would be fantastic from a speed standpoint if you could put a crane at every job site where a boardwalk is and just swing the pieces and then set the pieces very quickly, because time is money out there in the field. So equipment limitations is extremely important too. Several applications that have come up over the last 5 or 6 years has to do with some other things you may not have thought about. Think about heritage trees or protected trees. We've had many applications where a boardwalk is the preferred solution because there's protected trees or protected tree roots, and we're in discussions with the arborist that is responsible for protecting these trees, and they're very specific about where you can or cannot put not only the piers, but also what equipment can be running up and over that tree root system. We've got many examples where that's been the case. And then lastly, a popular one also is the sensitive wildlife habitats. We've got projects in Florida where there's a certain window of opportunity to build a boardwalk, and top down is being discussed. Is it the right option? Because there's a certain season, a certain time of day, and a certain methodology that can be used. And these are typically spelled out in those nationwide permits. There's a number for each of those reasons that you see on the screen. So my takeaway to you, if you're a design consultant, is think about, does the site or the permit actually demand top down, or could you do this in a different way? Could you bring in mats? Could you have a temporary disturbance to the protected area or not? Think about that when you're in the design phase. That's where it really matters. And your takeaway here is that those decisions, if you're thinking about those during the design, that's exactly the right time to do it. It's going to be incorporated into the budget. And those of you that have some experience and you've been through and you get those nasty change orders that are coming in afterwards, that can certainly make you look bad in front of the owner if you haven't thought of these things, and there's a surprise that comes as a change order. So if the decisions are made at the bid time or after the bid, then it most likely might be presented to you as a change order, which none of us on the design side for the boardwalk nor the ownership side want to see the change orders coming afterwards. You would like to say, well, we thought of that during the design phase, and this is the answer. So words to recognize. If you're a design consultant, these are some common phrases that we've seen in the permitting language itself, and you will be presented by the Corps of Engineers a draft. If you're involved in reviewing permits or obtaining permits for your client, look for words like no equipment in the wetland. That's very restrictive. Other words are no clearing outside the footprint of the structure. That's a little bit better. It allows the contractor more grace in the field. The picture you're looking at on the right-hand side is exactly that. The contractor was allowed to disturb within a specific footprint. The foundations were installed, and then the product itself was installed on top, and they installed the foundations, they backed themselves out, they came back and set the product on top of the pier system. And again, this is not a PermaTrak thing. This could be any boardwalk system, right? But that's very important. And you might say, well, why does it matter? Well, it matters with cost. As you get more restrictive with your top-down methodology, it's going to slow down the construction process, and it's going to make your overall project costs more expensive. Think time is money. The slower you go, the more time on the job for the contractor. No temporary access roads or mats are in the sensitive habitat. John Dove is going to show you a fantastic example where that was discussed on one of the case studies later on. That's very restrictive also, and that certainly limits the contractor for being able to access certain parts of the boardwalk. There's a boardwalk just a couple of miles from my office where they had no access roads were allowed, so that they had to build a boardwalk from the top because it was the only way in and out of the job site. And then lastly, no work is allowed between the spawning or the nesting windows. Again, has to do with the habitat that's on your protected area of your job site, and you need to be looking for that language in those permits. And my recommendation in the tip on the bottom of the slide is that you as a consultant should be involved in reviewing those permit applications, those permit drafts, and looking for these words and asking for clarity. I would ask for them to be very specific. Ask for some allowance for possibly a 15-foot corridor, a 20-foot corridor. Could there be a temporary disturbance? Are we allowed to bring mats and then remove the mats and then set the product from the top? That's what we would call partial construction via top-down construction. And I'll explain that here in a minute on a few more slides. So John has explained what the PermaTrak system is, and let's go to the next slide. I want to share with you how the PermaTrak system is installed and what typical construction equipment is, so that you can understand how a concrete boardwalk system can be installed. Method one, this is what we all want, where we have a nice piece of land. It can be contractors can move around on the land easily, and there's no limitations. Generally, small equipment like what you see here in the picture, they're free to go, and that's a 500, 700-pound piece of concrete that's being moved around. So skid steers, mini excavators are very common, very inexpensive to rent on a daily rate, and you can move around and set the product very quickly. That's what we want, but that's not what we always get. So method number two is with some mid-size equipment. You see a telehandler in the picture here. Obviously, they have a longer reach, right? They can pick up some heavier pieces. Sometimes the pieces on a precast boardwalk system may become several thousand pounds, and you might need equipment like this to pick up and then set at a greater distance if need be. But again, this is very common. These what we see on a lot of greenways and trails. And again, this is not top-down construction yet. That's method number 4. Method number 2 is we can move around anywhere we want. But these are the questions you should be asking and thinking about for your owner as a design consultant. Can I do that at my site? Large equipment, cranes, crawler cranes, as you see here, those are wonderful. Contractors would love to have a crane. You set up one time, you swing, pick up the piece, and you set it in place. Maybe you're sitting on a body of water. You can set a whole boardwalk sometimes with a crane, but it's not always the right situation, right? Remember a few slides back, I said, maybe you just simply can't get the equipment to the site, and maybe it just doesn't allow you to move a crane to the site. Now, method number 4, that's why we're here to talk about today on these slides. Top-down construction. As John said, top-down construction is where methods 1, 2, and 3 has been evaluated, and you're simply left with only one option. You have to build it from the top. You're not allowed to potentially disturb the ground. You're walking yourself out along the boardwalk. And in the picture you're looking at there, on the right-hand side of the picture is a skid steer that's delivering a product to the excavator on the left-hand side. The excavator picks the piece, swings 180 degrees off the picture, and sets that product in front of itself, and it builds the boardwalk as it goes. So the equipment is sitting on the boardwalk, and you're moving along and building the boardwalk as you go. Think about the time that it takes to do that. Think about the speed. Think about the delivery process. It all slows the process down, right? So it shouldn't be a surprise to you that this is going to become more expensive because it's going to slow the process down. And you might wonder, well, how serious is this, Jason? Why can't we do top-down on all the projects? We looked back at our records, and of over the 750 structures, we believe that there was approximately 60% of those conversations we talked about top-down. It was evaluated. It was brought up, or we brought it up because we saw something possibly that the consultant didn't see. We discussed top-down. But at the end of the day, we and the consultant came together and answered the questions, and we decided it wasn't a requirement. It was more of a want. And actually used top-down was more like 7%. So it's talked about a lot. It's not actually done in the field a lot. And if you've got contractors are saying that this is what we always do, it doesn't always have to be done that way. And next slide is the 3 methods of the top-down constructions. Let's go to the next slide, John. So the 3 types of top-down. Now that we're talking specifically about top-down, yes, there are variations of it. Just because you say you want to do top-down doesn't mean it's always the same methodology. A partial top-down, which many people still say is top-down construction, and I would vouch for that also. And the Corps of Engineers would say this is top-down construction also in many cases, but you have to explain it. Partial top-down construction is where you're allowed to disturb the footprint and build the footings from the ground. In this example on the picture, they were able to pour in place concrete piers. They set the piers first, then they backed themselves out, and then the product, the PermaTrak, was then set from the top. And examples of equipment that you can put on top of the PermaTrak are, these light cranes, an 18,000-pound crane or a 16,000-pound excavator or a bobcat that's 11,000 pounds. Those are typical weights, typical construction equipments that can run along the top of a PermaTrak system. The standard pieces of PermaTrak. PermaTrak, being that it's concrete, has the flexibility of designing for much, much heavier loads if need be, but it has some implications. I'm giving you sort of the standard, what we've seen most commonly used. Think in terms of 10 to 20,000 pounds construction equipment sitting on the top. There's probably a really good chance that those can be supported by the boardwalk and can be used to do some type of method 1, 2, or 3 top-down construction. So that's partial top-down construction. Let's go to method number 2. Method number 2 is actually a full top-down construction where you're installing the foundation system from the top, but it's very specific to the use of helical piers. Helical piers is a A lot of people call them screw anchors. They're twisted, they're torqued into the ground. There's a metal pipe with a helix on the bottom. Those can be installed with a fairly light equipment. An equipment that has a reach of say 10, 12, 14 feet in front of where you are can reach out and has enough down pressure, enough crowd to torque a helical pier into position. And then once the piers are in place, you can imagine from the picture, you look at the beams that are stringers, the stringers then are set from one pier to the next. And then the treads, like what you see in the picture there, that excavator is swinging a tread towards the man in the yellow. He sets the treads, and once he has the bay built, then he moves the entire operation one span forward, and the process is repeated. And then method number 3 is also a fully top-down constructed boardwalk system, but it's a different type of pile system, right? So this is a vibrated pile system in contrast to a hammer installed pile system. So think about vibrating a pile. Generally, they're going to be lighter piles. They're going to be, say, a timber pile, and we've seen composite piles. Those are two types of fairly light piles that can be vibrated or pushed into the ground, and then maybe slightly tapped at the end to get the capacity that they need. In the picture you're looking at there, that's approximately about a 28,000 pound piece of equipment sitting on the boardwalk. So again, the concrete has the capacity to take these larger loads. But this is going to slow the process down. The bigger the equipment, the shorter the reach. Again, those are going to slow the process down. So let's go to the next slide, because method 1, 2, and 3 can have different impacts on the cost. Method 1, partially top down. You should be thinking, boy, that sounds quicker. It definitely is. You're going to build the foundation, then you're going to rock and roll on the installation of the boardwalk system, and you might set 50, 100, 150 feet a day, depending on your site. So you're going to go a lot quicker. You're going to have less time with the contractor on the job site. Methods 2 and 3, because of the limitation or the impact of the spans, is simply just going to slow down how many bays or how many modules can be done at one time as you go. So it does impact the cost, with method 1 being the most cost-effective one. And we've sort of given you a very loose relationship to traditional construction. Traditional construction, think about it, you have free roam. You can go anywhere on the job site, you can use any equipment you want, and you can go very fast on a boardwalk system. I can tell you that methods 2 and 3, typically you're talking about building 1, 2, or 3 spans in a day. Think about spans of 10 or 15 feet. You're talking about going 10 to 40 feet in a day, right? If you were doing methods 2 and 3. Method 1, you could go certainly 100 feet in a day, 150 feet in a day if the conditions are right and the contractor's organized and properly prepared. So time is money, and that's why we have that impact on the methods. So this next slide, and this is the last slide before I let John Dove show you some case studies, is think about the material. We're talking primarily about precast concrete, but I can tell you we've seen these other boardwalk systems in action also. These are some of the materials that PermaTrak competes with sometimes, but timber is your most common, but timber is also going to have the less strength. Timber is also going to give you more flexibility. Timber you can cut in the field, and you can add pieces together, and you can build it as you go, so to speak. So you have that flexibility in the field, but you have much less strength to be able to handle some of those heavier loads. Composite is less used than timber or concrete for boardwalk options. I often see those in residential settings, not so much in commercial boardwalks. And then, of course, precast concrete. We have standard sizes. We can give you some standard numbers on costing and spans and things like that. But at the end of the day, a concrete component can be made to whatever width and depth you need it to be. And so there's a lot of flexibility, unlimited structural capacity, and you have that flexibility to really size the members to support the construction equipment that you're trying to put on the boardwalk system. So with that, I'm going to turn it over to John Dove. He's going to talk to you about 3 case studies, which I think you'll enjoy.
Thanks, Jason. Good afternoon, everyone. I'm Jonathan Dove. I'm a project consultant with PermaTrak, and I'm just going to go over a few of the case studies that we put together on various top-down methods. And so the first case study that I want to go over is partial top-down construction. So this is a project called Jean Lafitte National Park. It's down in Louisiana on the kind of south of the Boot, right underneath New Orleans. Okay, and so this is kind of our finished photo of what we installed. The before photo of this is like a little 4-foot wide, just some boardwalk planks, timber boardwalk planks that were super old. This area gets bombarded with water, as you might imagine. And so they needed to replace the boardwalk. They didn't want to go back with timber. And so they ended up using precast concrete to build the boardwalk. And with the national park project, like you might, think, the parks folks, they don't want the construction equipment running all over the park, right? They're trying to preserve as much of the natural environment as possible. And so we did talk about just doing true top-down construction where we do everything from the top, including the foundations. But this project, they were able to permit the, essentially the boardwalk footprint as the construction zone, so that they could drive in to this site, because there was further construction to be done past the boardwalk. And so using that kind of existing boardwalk footprint as the area to impact is what they ended up permitting to be able to use partial top-down construction. And so again, with partial top-down, once we get our design in place, you're going to do all the foundation work first, and then you install the precast from the top. And so this is what that looks like in practice. So the photo on the left is just a good shot of what the foundations look like when they're installed. So again, they were working from the back of the page back to the front of the page, trying to install all these foundations. Once they got all the foundations in place, then they began the operation on the right-hand side of the screen, where they are installing all of the precast from the top, right? So just using a standard mini-X, lifting and placing all the equipment, doing all the mechanical connections as they go. It's not as fast as traditional construction, but this is by far the most cost-effective way to do a top-down construction if you can get that right-of-way permits. This is a very good construction method. Okay, so case study 2, this is a project called Shot Pouch Greenway. This is in Sumter, South Carolina. This is a large boardwalk in Sumter. This is a big 12-foot clear boardwalk. And so they actually bid this project as true top-down. And we'll see that they ended up having to deviate to partial top-down here in a minute. But what ended up happening here, they bid this one as actually a timber structure was the base bid. PermaTrak was an alternate. The owners ended up going with PermaTrak because they liked the idea of a long-term boardwalk solution that was very low maintenance, right? And so you're not paying some massive premium to be able to do that, right? And so, but the real value I think that we brought to this project was when we ran into an issue in the field. So again, we're planning top down. We're going to do this is all the helical piers. We're going to install all the helicals from the top. But what ended up happening is you can see from this picture, the site is very dense. There's a lot of large trees and large tree root systems that they're trying to get these helical piers installed in. And there's really a good story of just our pre-construction meeting and what happens in that meeting. So we put a design together, like, okay, we're planning top down. This is what we're going to do. In the pre-con meeting, we talk about all the things that we need to pay attention to when we are installing our system. And one thing that we call out with helical specifically is that you really need to be close with where the helical location is. So we provide the location pier tops as well as the exact location that the pier needs to be, because again, we're precasting these beams and we're delivering them to the field. And so especially with a helical system, we need to be pretty close to right when it comes to where that helical pier top is facing up. What they found in the field as they started to install the helical piers was that helical piers were not going in very well. Again, all the tree roots that they were encountering, as well as the site was a bit drier than it normally is. And so that was something that was unanticipated. And so they put up the red flag that said, hey, stop, we've got to relook at this. They ended up talking to the owner. Because of this kind of struggle with getting the helical piers in the right location every single time, they ended up adjusting what was permitted, and they were able to use partial top-down construction so that they could get the helical piers in first. And what that allowed them to do was then they put all the helical piers in, and then they gave us an as-built survey of all those helical pier tops, so that then we could adjust the beams to suit the foundations that were in the field. And so that's what this clouded drawing on the left is showing. You could see the variability in the lengths of these beam members. That's not how we typically lay out boardwalks. We like to do the same thing over and over again. But when we run into stuff like this, our engineering team is available during construction for a project. And so if this were to happen, this is something that we can do. We kind of halt production while this is going on until we kind of understand the answer to what's going to happen, and then we try to come up with a solution working with the contractor to make sure we get something that's manageable. And so that's what ended up happening on this project. Again, picture on the right, very similar to the last project. We're doing all the precast from the top. So once the helicals are in place, then we are installing beams and treads on top of the boardwalk, not touching the ground, right? So we're still able to honor, the permitting of, making sure we're staying within the footprint of the boardwalk, but being able to deliver something in the field to solve the problem that was happening in the field here. Okay, then this last case study is Panther Creek, Greenway. This is in Cary, North Carolina. So this is a really interesting project where we were building a boardwalk underneath an overpass. This picture was actually taken standing on the top of the overpass, looking down at the boardwalk. This section view is a standard section for the city of Cary. They have adopted PermaTrak with some timber handrails, kind of as their go-to elevated walkway when they're putting a boardwalk into there. They've got a really expansive trail network all throughout Cary, and so this is something that we see a lot out there. Now, we don't always do top-down construction, and that's what happened in this specific scenario. We're cutting through a wetland as well, and so they wanted us to stay off of the ground. And so we built this project as a true top-down all the way. We did not touch the ground at all in order to perform this installation. This is a good example of using vibrated timber piles as well. And so when you're looking at this, on the left-hand side, we can see this is our typical section that you would see for a top-down construction project. Again, if you remember, this is the same picture that Jason went over that's got the 30,000-pound piece of equipment. So that excavator is pretty large. We don't typically put this big of a piece of equipment on the boardwalk. But when we needed to vibrate in the piles, this was the right way to go. You can also see when you're operating under an overpass, like driven piles was not going to be an option either way. We just weren't going to get the piece of equipment in there to be able to do that. So vibrating in the piles was probably going to be the answer either way here. And so it just ended up working out, well, that we could use top-down construction here as well. You could see we have timber piles. We have our timber pile cap that goes on top of the timber pile, and then we set our beams on those caps. And so when you think about this project being this is a 14-foot clear project, right? So when we're designing boardwalks, we design to ash toe loads. And so an ash toe loading for that width would be H10, which is a 20,000-pound vehicle. And so because we knew that we were using top-down construction and we needed to support a 30,000-pound machine, and not just a 30,000-pound machine, right? It's lifting on that right-hand side. That's a 5,000-pound piece of concrete is lifting as well, right? So we're looking at really probably a 40,000-pound live load scenario in this situation. And so we do have to upgrade our design to suit construction in this scenario. And so rather than have the standard use case or the standard ash toe live load be our design case, we now have to plan for the construction being the control as far as design goes. And so it's a little bit beefier design as a result of that. But again, easy to adjust and make those kind of changes when we're planning for it and not trying to do things post bid for sure. So with that, that's my last little bit on the case studies. I'm gonna hand it back over to John Powell to talk about specifications.
All right. Well, thanks, John. I've only got really a couple more slides to go through, and then we'll have some time to address some of the questions that we've already seen coming through. So if you do still have a few questions out there, go ahead and drop them in either the chat box or the Q&A box, and the ones that we don't get to, we'll be able to distribute some answers to those as well. So you just saw some 3 different projects, had 3 different answers. So luckily, kind of making a decision on which way to go is usually a little more simple than it may appear. When we go to this next slide, you'll see some questions that would need to be need to be addressed as you're evaluating your options. So that first question really kind of helps to separate where top-down is the right decision, or where it's really not required. So oftentimes early on, top-down construction is expressed as really more of a want than need. I can't emphasize enough that you really only want to pursue top-down if it's a need. We shared some numbers with you previously, showing the number of structures that have been installed, the number of the structures that have evaluated top-down. A very small percentage of them actually end up getting built with one of these top-down. So thankfully, in most cases, the answer to the question of is it a want or a need means it's no. It's not really required. So some form of disturbance is allowed or permitted, meaning traditional construction from the ground is the way to go. But if it is required, that's when these other questions really need to be evaluated and thought through. And number one is that permit requirement. What does the environmental permit condition? What do they allow you to do? And then that needs to be incorporated into the specification, so the contractor really understands what they can and can't do. Jason hit on site access. Oftentimes, site access kind of gets overlooked in this process. We think about the environmental implications or the impacts, but site access can also drive that decision on how to build. And if you have large trees, you have existing utilities. If you have a site that has a lot of cross slope to it, that may not be a good for operating equipment on it, and benching into the side of that hill may not be feasible. So, constructability really and site access can drive that. And then the next piece of information that's critical is the geotechnical report. I always encourage, get a geotechnical report as early as possible, because it's going to inform that decision as well. Jason mentioned the different methods of top-down construction, and those approaches can be very much influenced by the type of foundation being required by that geotechnical report. Helical piers are probably the best answer in most cases for a full top-down installation, but the geotechnical conditions may not support the use of helical piers. And so, that may force a partial top-down construction, or going back to the drawing board with your permit to get a full impact allowance. And so based on those the answers to those questions, it's also going to kind of inform your choice of material. The type of equipment that's going to operate on top of it may influence whether you use timber or composite or precast. As we've mentioned, we have a lot of flexibility with the design of our system to handle those kind of loads. But that needs to be thought through. And then, of course, budget. Anything can be done with enough money. However, not every project supports an infinite budget. In fact, I haven't met a project yet that has an infinite budget. So all of these things are going to drive or influence that decision on whether or not to proceed with a top-down approach. So going to the next slide, I do want to take a minute here to talk about what should be included in your specifications to make sure that you get what is required for the site and going to be in compliance with the environmental permits. Make sure the contractor understands how to efficiently bid and build a project, and then ultimately that the owner of the project is going to be happy. So, if you look at the first item, which method is going to be the best approach? So, is it a fully top-down using helical piers, or a fully top-down using a vibrated pile? Or can the contractor operate from the ground and drive piles? And as I mentioned, a lot of that decision is going to be driven by the geotechnical site conditions. So again, certain soils may not allow for the use of helical piers, or they may not allow for the use of vibrated piles. In those cases, if you're having to drive piles, you're most likely going to have to be able to do that, at least that part of the work, from the ground. And the next question that often has to get addressed is the allowable equipment. You should definitely consider putting that information directly included either on the plans or in the specification, so that everybody understands exactly what's going to be allowed. And the next issue that you want to address is that construction live load. So that kind of goes hand in hand with the weight for the allowable equipment. We've mentioned AASHTO loading here a little bit. Typically, AASHTO is going to require either an H5 or an H10. So either a 10,000 pound or a 20,000 pound piece of equipment based on the width of the boardwalk. Unless you have a special case where you want to have an emergency piece of equipment or some future maintenance piece of equipment that's heavier than H10. Typically, H10 is the maximum long-term design load. However, a lot of this equipment can easily exceed that H10 design live load. John mentioned that project in North Carolina that had it's a 30,000 pound excavator plus the weight of the precast concrete that it's handling. So that greatly exceeds the H10 design live load. So we take that into consideration when we're designing the boardwalk, but that extra weight and the pier reaction associated with those loads needs to follow it through to the foundation design. That pier load needs to take into account that additional the additional equipment loading, because not only does it impart an axial load, it can also increase the lateral loading, and the height of the boardwalk will also play into that. As far as whether or not you need a cross brace, take that lateral load into consideration when you're selecting the foundation to begin with. A lot of cases, PermaTrak is doing the foundation design, but in other cases, we're not doing the foundation design. So it's critical that the proper axial and lateral capacity is specified as part of the upfront bid package. And then the next item that should be considered is mats. So if mats are allowed and you're going to be able to work off of the ground in some capacity, clearly defining where that's allowed and where it's not allowed will really help the contractor kind of stay out of trouble and then protect you and your owner as well. So and then sequencing as the last part of it. If it is a partial top-down, just kind of defining the sequence of events. So again, that the contractor understands what they can and cannot do. And so, including this information can really go a long way towards saving future change orders and also protecting the integrity of your bid, the bid prices that you receive, to make sure that that contractors are accurately accounting for these items, so that they're not overestimating their exposure. So we've already reached the end here. I can wrap things up with just a few final thoughts. We're available to help evaluate upfront early in the design process whether or not a top-down or some version of top-down is the best result. We offer this service at no fee to you. We have a team of structural engineers who can help evaluate those construction live loads. I mean, we get those requests quite often with, hey, I want to operate this particular piece of equipment on the boardwalk. Can I do that? And as long as we know the model number, we're able to look at that and check the structural capacity of the boardwalk, as well as see what kind of impact it might have on the foundation reactions. And as we've mentioned, we've done over 750 structures installed to date, with a lot of those having some form of top-down. So we have a lot of references that we can draw on, and we can share those references with you as well. If you want to see a typical set of drawings, happy to share something like that. We can also assist with putting together the spec language for a draft spec for you. as well as construction drawings. And one thing we do with construction drawings, if you have a CAD file that you can share with us, we'll take a look at that and help optimize the span lengths. With precast concrete, as we've mentioned, we have a lot of flexibility to to either custom design beams and treads to accommodate a given span requirement, or use our standard system, either one, to help evaluate that. So I have seen a lot of questions have already been loaded into both the chat box as well as the Q&A box. So we have several. We'll get through as many of these here kind of live as we go, as we can. And any of them that we don't get to, we'll summarize those and get those out in an email to everybody with the link to the recording, as well as the copies of the slides. So John, if you want to share with us some of the questions that we've received so far, and we still have some time, so if you're still thinking of questions, go ahead and add those too.
Absolutely, yeah. Please, any questions y'all have, go ahead and drop them in the chat. And we're going to kind of round robin this thing. I figure I'll start with Jason. Maybe if you could add some more color to kind of top-down construction, and when and why it would necessitate stronger beams. Does it always have to necessitate stronger beams? Is it, what's kind of the story as far as how it would impact our specific design? What can our standard design handle? When do we need to really, change our design to suit construction loads?
Sure, I'd be glad to answer that. Elliot, thanks for waiting. I know you were the first one with a question there at 17 minutes in. So yes, your question is a very good one. Does top-down require us to increase the size of the beams or modify the beams in any way? Not normally. Not normally. We would try, we as a company would try to use our standard pieces, right? So we know what the normal dimension, height, and width size is of our beams. We know what the standard size capacity is. For us, a standard beam would be 14 inches tall, 20 feet long. And we know what the reinforcing is for that. Normally, something under 20,000 pounds, Elliot, would normally not require us to increase the depth of the beam, the width of the beam, or the rebar. So I would say no, not normally. Sometimes during the bidding phase, and this happened on several projects recently, where one particular bidder said, "Hey, I don't have the equipment that the engineer put on the plans that was the assumed top-down equipment. I don't have that. I can't get that, but I do have this one available. I own this equipment. Can I use this one?" And it was 2,000 or 4,000 pounds heavier. We ran the numbers. The dimensions of the pieces didn't change, but we had to add rebar to the beams. We had to increase the steel, which cost us money, right? So that we had more steel in those pieces. So like John Pyle said, if the designer does a good job on the bid specifications, declares what the assumed construction load is, then everybody's on the same playing field. Contractors who want to go bigger and heavier certainly can, but it's going to require a change, and that particular bidder may just have a higher material cost. So normally, no, Elliot. I would say it normally doesn't require 20,000 pounds and under. You should be okay.
Great. And then our next question is about method one. Just to be clear, so on the method one example, and I can just show you this real quick. Again, method one is partial top down. So they did they performed the foundation installation first, and so they did impact the site to get to the foundations, right?
Yeah.
I don't know if on this project if they particularly pumped the concrete or if they drove a concrete truck back here or whatever to get the concrete back there, how they got the concrete back there. But you should note, for partial top-down construction, we are permitting that we are going to impact the ground underneath the boardwalk to install the foundations. Okay, the next question is, what is the depth of the helical piers that they can, what depth can they reach using top-down construction? That's the first of three questions here.
Yeah, I can take a crack at that one. So helical piers, the depth is ultimately going to be driven by The information is contained in the geotechnical report. But helical piers are basically segmental. So they have segments, sections that vary from 5 feet to 7 feet long, and they just keep adding segments bolted together until they reach the depth or they reach the resistance that can be correlated to a capacity. Often, I mean, we see them anywhere from 20 feet to 30 feet. I don't know that I've seen a few of them proposed at greater than 30 feet. I think when you start getting in that depth range, maybe time to consider an alternate foundation type. But the helical piers is one of those systems I mentioned earlier that in some cases PermaTrak will design the foundation, other times we do not. Helical piers is a foundation type that we do not design. Most of the time that is a delegated design. They're kind of a specialty subcontractor involved. So usually the helical pier providers, manufacturers, they design their own systems. But you can just keep bolting additional segments until you reach the depth, and then that needs to be correlated with either a load test to confirm that capacity, or some of the manufacturers they have some torque charts that they can relate a torque to a pile capacity. But our recommendation is usually to do a full load test to confirm capacity of a production pile before you start installing.
Perfect. Okay, thanks, John. Then slide 19. Maybe Jason, you could talk to this a little bit. This is asking to kind of explain our methodology around this illustration. Asking, is this typical boardwalk construction? Is this, is PermaTrak a premium to this, or how do we get to these numbers?
Oh yeah, what we're showing you here, Nathan, is a chart based on traditional construction for PermaTrak traditional construction. We're giving you an order of magnitude of PermaTrak being used on all of these cases, traditional or all the three methods, and how the cost impacts that relative to the baseline of a PermaTrak traditional boardwalk system. Yeah, good question.
Perfect. And then for the finishes that are available for the decking, so on the boardwalk decks themselves, there's a few things. There's color and there's texture, right? And so we have two standard texture options. We have a timber texture and a sand texture. And we use those textures, or how we achieve those textures, as I say, is by casting them into our treads. So we actually cast our treads upside down and use a form liner to create the texture on the tread. And that texture is there for two reasons. One is aesthetics, just we want it to look nice and not just be a giant slab of concrete. And then also safety. So we've had third-party testers test the friction on these treads and found that they maintain friction well when they're wet, right? And so if you've ever walked on a boardwalk, you've seen a slippery when wet sign. Texturing concrete does a really good job of maintaining friction. So it's a good way to add a safety feature to your boardwalk. Now, that's texture. The other thing is color. So we use integral color with our boardwalks. We have two standard colors. We have a tan color that we call Melbourne tan. It kind of looks like a fresh new piece of timber. And then we have a color called Adelaide gray, which looks, if you match it with a timber texture, looks like an old weathered boardwalk. You know what I mean? And so we have those two as a standard. We do have another color called Savannah brown that takes a little bit more pigment to achieve, and so we call it a premium color. And those are our kind of standard color options. You can also opt for no color. That's natural concrete, right? So it's going to look like any other sidewalk that you have on the site. So you can do a lot to mix and match color and texture on the treads to kind of make them look like what you want to. Now, if you deviate out of our standards, it's going to come with additional costs, but it's nothing that we can't likely source if that's something you were interested in.
And John Dove, I don't know if you said, but the two textures we offer is a beach sand and a beach wood. So there's a timber looking texture and there's a sandblast looking texture on the top surface of the tread only.
And I did just happen to see a question, John, that's related to the texture question that kind of popped up just a second ago. I don't know if you saw that one yet, but there was a question about whether or not operating tracked equipment would impact or damage those textures. And I think there was another question about a general question about whether or not tracked equipment or operating equipment on top of the boardwalk would damage it. We always recommend putting some kind of a protection down over the boardwalk. What most commonly happens is if it's a rubber, like a tracked vehicle with kind of those rubber tracks, it'll mark the concrete more so than damage it. So normally you'll see some fabric laid down to protect it. You may see contractors use timber. In this case, they were using like crane mats to not only protect the boardwalk, but also to help distribute the weight of that piece of equipment. So it's a great question. It does need to be thought about because you certainly can inadvertently, a contractor, if they're trying to pivot that piece of equipment on a boardwalk without it being protected, they can definitely mark it up and potentially scar or damage the precast. So that needs to be thought through. And when we cover that in our pre-construction meetings with the contractor.
Absolutely. Thanks, John. Jason, we've got a question as to elaborate a little bit about the timber, strength of a timber boardwalk. So I think this is related to material selection. So just, timber boardwalks, can they handle heavy loads, pedestrian loads versus vehicular loads? Can you explain a little bit more about the limitations of timber when you're trying to build a boardwalk?
Sure. I mean, so without going into the true science of structural engineering, logically, right, you look at a piece of timber compared to a piece of concrete, there's more strength in a concrete component than in a timber. Timber boardwalks absolutely can be used for pedestrian loading on boardwalks, absolutely can be designed for vehicular loading, such as an H5 typically is the first level 1 vehicular load. I can tell you from experience that timber boardwalks, once you start requiring H10, which is any boardwalk wider than 10 feet, the timber boardwalk designers have to start going outside of their normal procedures. You will start seeing thicker and taller and double and triple stringers. Stringers will be held closer together. Deck boards will be thicker. Instead of a 2-bys, they might be 3-bys or 4-bys, right? And they just get bigger and heavier. And there's a reason why bridges on the highway are concrete and they're not timber, because of the strength. And I'm not saying that to be insulting, but there are vehicular bridges. There are companies out there that do vehicular bridges and they do perfectly fine, but they're not with standard pieces. They're going to be with glulam beams, specialty built timber beams. They can be used, but they simply don't have the longevity that's going to be required for vehicular, heavily traveled vehicular bridges. But yes, they've been used on loads that require heavy loads. They can be, but it requires a lot more modifications than you might see out of a concrete boardwalk system.
Great, thanks, Jason.
Sure.
Let's see. Next, let's go here. John, could you talk a bit about so the partial top-down example? Let me just see. Okay. The question is, are these precast foundations? And I guess, good question probably to follow up with that is, can we use precast foundations for top-down construction? What's the limitations around those, that kind of thing?
Yeah, that is an excellent question because that certainly is concrete, but no, those were cast in place. So what that foundation that you're looking at is they installed helical piers below grade to distribute and take the load down into the more the denser substrata. So they installed helical piers and then they formed and poured kind of a member that ties those helical piers together and then a vertical element to bring it up to grade. So that's a cast in place system that you see there. The challenge with a precast foundation system is if you're trying to install a deep foundation precast, that usually means big, heavy, 12 by 12 or 14 by 14 precast piles that are going to be long and have to be driven in with a very large, a crane type of pile driving setup. So that is not going to be conducive to doing it top down from the boardwalk. You can do that if you are able to work off of mats and install those those piles not from the boardwalk. And then you can come back and install partial top down that way. So the limitations around precast really have more to do with the type of foundation and what would have to be done from the boardwalk to be able to get those foundations in.
Okay, perfect. Thanks, John. And there's a question here about, does PermaTrak own and operate our own precast facilities? We do not own our own precast facilities. We work with third-party partners that we build a relationship with and work together side by side on to manufacture the boardwalks. So we have a production team whose whole job is to kind of work with those precast companies, work with contractors in the field, organize the delivery of everything. We do have a production team that focuses on that, but as far as like having an actual facility where we have people that are pouring the concrete, that's a third party that we're working closely with to make that happen. Let's see. The next question was around design. How do you typically evaluate? So Jason, maybe for you, how do you typically evaluate foundation alternates for a top-down approach when early access is limited and so you don't have great initial geotech data? What do we do there?
Yeah, good question, Luke. I saw your question pop up. So you have to lean on your experience in the past. You are correct. You're not going to know what the soil is telling you about the foundation system. So at that point, the best you can do for the owner or for the design consultant is to make some assumptions. Maybe you've done something that's close by. Maybe you've seen structures. We can make an assumption that helical piers work, and that implies certain restrictions on beam length, right? So it simply is based on experience. Now at PermaTrak, like we told you, we've done 750 structures that have been installed. We do have access to many of those bid results. Some of them are helpful. Some of them are broken out where we can see what that labor cost is. We have a sense for what cost per linear foot might be on certain scenarios in certain parts of the country. So our sales team will pull that knowledge together. Certainly, we can control the material of the PermaTrak costs very tightly. The rest of the story, the installation, the contractor's time, we can give you ballpark ranges of what those are. And then when we get into design build scenarios with contractors, we just explain to the contractor, this is what we've seen from past installations. This type of pile system will allow you to go with certain loads to it, with certain spans. And we work with the contractor to try to estimate what we think that daily rate might be, daily production and installation rate might be on projects. So it's hard. It's very hard when you don't have a geotechnical report. And by all means, we would always recommend that gets done. And I know, Luke, that's not your question. You got to get the geotechnical information, especially if you're the consultant. You got to get that geotechnical report, or you're just completely guessing by the time the bids come in. And it can be an ugly sight there because bidders and contractors are just going to, if you're asking them to take a guess, you're going to get wild variations in the bid results. So I hope that's answered your question, Luke.
Thanks, Jason. Then Marshall, yes, we will be sending out a copy of the slideshow so that you can have it as a reference. Thomas, you have a question about foundation design. So yes, so PermaTrak, we are a structural engineering team. We do the structural foundation design on probably 90% of the projects that we work on. Occasionally, we will be working with a third-party engineering company that has ownership over the structural design for one reason or another. You know what I mean? And they need to own it. And so they will say, no, we really need y'all to just do the precast. So in that case, we'll do the boardwalk design and we'll give them the pier loads that they can then use to incorporate into their foundation design. So we're happy to do it either way. But yeah, we are, as far as ownership of the foundation design, if it's something you would want us to do, we're happy to do that. John, we have a question about just construction economics and the methods evaluated. Seems like something like a large 40,000 pound excavator would drive cost up for thinking about only construction and not thinking about kind of the typical use case of the boardwalk. And so our construction methods and cost evaluate beforehand to see if there's a better, more cost-efficient way to construct the project. Is there, what's a good way to answer that question?
It's really, that can be a challenge. We only have the information that's available kind of preliminarily. So I've oftentimes will provide a couple of different scenarios of what we think the estimated cost to install it would be based on some assumed values or some assumed foundation types. I always encourage consultants and owners when you're looking at sort of these non-traditional or non-standard construction approaches like top-down to evaluate all the options. Think about whether or not, again, does it need to be built top-down, and if so, which one of those methods is going to be the way to do it. We're happy to run as many different pricing exercises as you would like to evaluate different options, different scenarios. That happens quite a bit in design build world where, there may be one idea that the design build team goes in with using a particular type of equipment or spans foundations, but we start getting further into the design and we realize, yeah, this is starting to get expensive. Let's look at some other options, and then we'll put our heads together and think of other foundation types or other construction approaches, different span options. We have a lot of flexibility to vary all of those.
Okay, thanks, John. And then Jason, we have a question about publicly bid projects where you can't sole source. Are there third-party products out there that are similar to PermaTrak? How do we work on a public project where we can't necessarily be sole source?
Yeah, good question, Nathan. I mean, on a publicly funded project, most of the time what we see is that the consultant has pulled together a performance specification. They're going to go in with what it is that they want. They're going to show a cross-section of what it is that they want. And let's, for the sake of argument, just say that they've chosen that they know they want a concrete boardwalk system. Sometimes the consultant shows a formed in place concrete boardwalk system. And PermaTrak comes along and we compete against a formed in place concrete boardwalk system. We have one right now that's going exactly that way here in North Carolina. Sometimes they show PermaTrak as the basis of design, and then a contractor, sure, they could build this thing in place. Or you could put on there a local precast company and they could provide a precast boardwalk system. Now, the beauty of as you know, Nathan, of PermaTrak is we have all that in place. We have the engineering system and the team. And if you were to put some precasters, they may or may not be interested. They may not be interested in trying to figure out how to design a precast system. To explicitly answer the question, are there other precast concrete boardwalk systems in the United States with engineering staff like us? No, there's not. We're the only one that does this in the United States. To be very blunt with you, we're the only one. But publicly funded jobs account for probably 725 of 750 projects that we've installed in the United States. So you absolutely can show a concrete boardwalk, sometimes call it a PermaTrak boardwalk or approved equal, or you can say precast concrete boardwalk system, and you can say in the specifications, PermaTrak was the basis of design. And that's typically how it's been done. If you want to see some of the very specifics, Nathan, I'll give you some great specific examples from some of the big consultants. I don't know who you work for, but I've got some plenty of examples we can send to you, Nathan, on how you might do that. So rest assured, yes, it's been done over and over again.
Great, thanks, Jason. We have a question, interesting question on foundations, John. We show our standard profile with 2 piers. Have we ever done projects where we've used just a single pier in the middle rather than have 2 piers side by side?
Yes, we have. Not done one top down though. That mono pile is what I always call it, but a single pile is going to require, at the top of that pile, is going to have some kind of a hammerhead arrangement. Typically, cast in place concrete is the arrangement that I've seen before. It just doesn't lend itself very well to a top-down construction. And I'm thinking specifically of a job we did in Arkansas. They were very high elevated, going over a roadway. Picture what you might see driving down the highway for an interstate bridge, where you have these big hammerhead single pier supporting an interstate bridge. That was kind of the same approach. So our precast beams land on that single common header, if you will, that's coming off of that single pile. So yes, we've seen it done, but not on a top-down basis.
Okay, great. Thanks, John. And let's see, the next one is about curves. I think we had a couple of curve questions. So I wanted to, let's see, I'm gonna get back to this slide. Okay, cool.
Curves?
Yeah, curves. Let's go back to
that overhead view from
this
Panther
one right
Creek.
here.
There you go. That one.
Yeah, okay. Yeah, so maybe talk about how do we include a curve in our boardwalks? How does construction of a curve take place?
Yeah, so we will work in some trapezoidal shaped treads. So you picture those treads normally for a straight boardwalk, they're just big rectangles. So to get that curve, the inside radius will have a shorter length. The outside radius tread has a longer length. So it's just a kind of a segment and chord going around that curve. And you can see with the railing installed on it, it really looks just like a long continuous radius. It doesn't look like a segment and curve. So the beams are much more pronounced on that chorded or segmented approach, but they're covered by the treads. So you just don't see it as much. So the beams on the inside of the radius will be shorter than the beams on the outside of the radius.
Perfect. Thanks, John. And let's see, question about vibrated timber piles as far as longevity, like how long do these last in a marine or brackish environment? And are there alternatives to timber piles that, maybe hold up longer? Jason, you got anything about that?
Oh, Marie, what a question, Marie. Okay, so timber piles in a brackish and marine environment, you see them all the time. You see them on walkways and piers down in Florida. They're all over the place, right? So I don't have a specific answer for you on how long they're going to last, especially if you're going to vibrate versus driving. I'm sorry, I don't have that answer. What I do have a partial answer for you is that the alternate that we've seen is that the timber pile would get poly wrapped with a composite, or you would just simply use a composite pile. And we've seen that happening more and more with a composite pile. A composite pile is just a pipe open section pile, and it can be vibrated or driven in place. It can be used on boardwalks or fairly low loads for piles. Timber or composite can handle those loads. Composite is a very good alternate to a timber pile if you're concerned about how long it's going to last in that type of environment. Sorry, Marie, I couldn't tell you how long those things would last, but composite is probably where I would lead if you needed to get away from timber.
Okay, and as a follow-up to that, I see a question about curved treads and how do they get installed, as far as are they numbered or anything? And that's a question contractors ask us all the time, is like, how am I going to know what all this stuff is? And what we do is when we deliver our construction drawings, a lot of contractors end up saying it looks like Legos for grown-ups. What we have is a bunch of beams, and they're all labeled like B1, B2, B3, and then we have a bunch of treads, and they're all labeled T1, T2, T3, and then we have that on the plan so you can see exactly what the next piece is. And so now if we have two that are the same, they will both be labeled T1, but if they're different in any way, they get their own individual indicator so that they know, oh, this is the next piece, and they can go find it, grab it, bring it to the site and get ready to install it. So yeah, we have a really structured way of identifying all of the individual elements on the boardwalk as they're being built, to try and make it as straightforward as possible when it comes to the installation. We do have another question around helical piers. Maybe you could take this one, John. Could you talk about the standard kind of pipe diameters that we see on projects, and also how do helical piers connect to, or how do we connect our beams down to the helical piers? How does that work?
Yeah, those are both really good questions. So we see a lot of helical piers that the design comes, we finally see either design submittal, or we'll see some details, or the contractor will just tell us what they have. 2 7/8 diameter shaft appears to be kind of an industry standard, very commonly used in a lot of applications that do not involve top-down construction. And it may be appropriate for top-down as well. It really depends on the spans, the loads, the lateral load. We've seen that size used on top-down too. So that's a very common, probably the most common. And then it starts to go up from there. So you may see a 3.5-inch diameter. I've seen up to 8-inch diameter helical piers. They can get to be very, very large, and the loading is what's going to drive that decision. And then how tall is the pier above the ground, because they're slender members. They don't handle lateral load by themselves very well. So you handle that a couple of different ways, either upsizing the shaft diameter, or you can cross brace, tie them together to help improve that lateral capacity. I've seen them installed battered to help with that lateral component. So it's one of those things. Again, we don't provide that final helical pier design. That's going to be done by a helical pier designer. So we refer to or defer to that designer. We'll provide them with the pier loads that they should be designing for, but it's really up to that helical pier designer to evaluate those pier loads and then provide an appropriate design to handle the axial and the lateral loads. As far as the connection to the beam, you see here on the screen on that left, that detail is a plan view of a typical helical pier cap plate. So that plate sits on top of the helical pier. It'll have slotted holes in it to give us a little bit of lateral tolerance and flexibility in the field. And it's just a simple through bolt connection. We preform a hole in the beam. A threaded rod goes through the hole in the beam, connects to the bottom side of that plate, just a simple nut and washer. And then same thing at the top of the beam that gets connected with a nut and a washer. And so that's how those beams are then connected to the foundation.
Great. Thanks so much, John. I believe that's all of the questions that we had. So I'm just going to cruise ahead to our thank you slide and thank everyone for attending the presentation. Please reach out to us with any kind of boardwalk ideas or projects that you'd like to take a look at PermaTrak on. And yeah, reach out to us anytime if you have any question. If you don't get a follow-up email from us, which you definitely should with the presentation, please reach out. We're happy to get that info to you.
Thanks, everybody.